In this video, we're going to be solving this question. A body moves on a circular path of radius 25 cm at a speed that increases uniformly from 5 meters per second to 8 meters per second in 2 seconds. Now we have to find the angular acceleration of this body. Now to start with, my last presentation of video, I did explain that we have the total acceleration of a body in circular motion, which is, the total acceleration consists of the vector sum of the tangential acceleration and the centripetal acceleration. And that the tangential acceleration is given by the angular acceleration multiplied by the radius of the circular path. That's the expression, that's the formula for calculating the tangential acceleration. And that the centripetal acceleration is given by the constant speed squared over the radius of the circular track. Okay, and that these two accelerations can be represented like this graphically. Let's say you have a body in the circular path moving in this circle, and that at the point A here, the tangential acceleration is directed along the tangent at A. So I can call that AT to denote tangential acceleration. And it is the same direction as the direction of the speed of velocity of the body at the same point A. So that's why you can see that for the body's velocity to change, then it means that it must have this tangential acceleration because it is in the same direction as the direction of the speed. And then, so which means when the body moves with a constant speed in a circle, it does not accelerate. That is, tangential acceleration will be zero when the speed is constant. So that for this speed to be increasing around the circle, it means the body must maintain this tangential acceleration. Now, in the same vein, the centripetal acceleration will not be zero. And that one is directed towards the center of the circle. So you can see that when the body moves with a constant speed, though this is zero, this is not zero. This centripetal acceleration is therefore responsible for the changing direction of this body. Though moving at a constant speed, the direction keeps changing because at this point, the direction of motion has changed. It was directed like this at point A. Now at point B, this is how the body is directed. So that shows that though a body moves with a constant speed around the circle, its tangential acceleration goes to zero. It's equal to zero. It does not accelerate in that direction. But the centripetal acceleration is not zero because it is given by the constant speed squared divided by the radius of the circular path, r, and that it's only responsible for the changing direction. You cannot increase the magnitude of the speed because it's not in the same direction as the direction of the speed. So what this AC does is to change the direction of motion of the body, though the speed is constant in magnitude. So this question says we should find, and again we can still write that tangential acceleration is given by change in the velocity with respect to change in time. And here we see that the body moves with a speed that increases uniformly from 5 to 8. So which means the change in velocity is going to be the final velocity 8 minus 5 divided by 2 seconds because it takes 2 seconds to achieve that change. So my tangential acceleration therefore equal to 3 over 2, which is 1.5 meters per second. Okay, so we have to find the angular acceleration. Okay, that's what the question says. Look at it, find the angular acceleration of this body. So very quickly, the angular acceleration is found from tangential acceleration, which is again given as the angular acceleration alpha multiplied by the radius of the circle. So that gives me alpha is equal to AT divided by r. I've got my tangential acceleration already as my 1.5 meters per second squared, then divided by the radius of the circle, which was given in the question. 5, that's 25 centimeters, can divide that by 100, that gives 0.25. All right, so when you divide this by this, it's more like multiplying 1.5 by 4. That gives you 6.0 angular acceleration radian per second squared. So that is the solution to this particular question. Now let's look at the second question. Now it says that what is the magnitude of the acceleration of a particle which is moving in a circular path of radius. See, it's moving a circular path, and you are given the radius of the circular path. So what do we do here? Let's see solution. No, with uniform speed, if it completes the circle in 5 seconds. Okay, since we are told that this body completes its cycle in 5 seconds, we can find the constant speed with which it is moving. So speed is given by distance covered by the body divided by time taken. This is how we define constant speed. And what is our constant? What's our distance? It means it is same as the circumference of the circle, 2 pi times radius of the circle divided by time t, which is in 5 seconds. And then we're given the radius of the circle as 20 centimeters. We need to express that in meters. So that gives me 2 times 22/7 times 0.2 in meters times time t, which is 5 seconds. So we need to evaluate this quickly. So that will give us 44 times 0.2. That will give me 8.8 divided by 35. So I can quickly evaluate that with my calculator. Okay, that gives me 0.25 meters per second. That's after computing 8.8 divided by 35. Now that is the speed, and you need to note that this speed we have calculated is constant. Come back to the question again. Say the body moving in a circular path of radius 20 with a uniform speed, and then it takes 5 seconds to complete its circle moving at that uniform speed. Now you should know that since the speed is uniform, the tangential acceleration, which is acting in the same direction as the direction of the speed, will be 0, because since the speed is constant, tangential acceleration is 0. But the radial acceleration or centripetal acceleration is not going to be 0. So the question here is asking us to calculate the magnitude of the acceleration. So the acceleration referred to here is centripetal or radial acceleration, which is given as v squared divided by the radius of the circular track. So that gives me my 0.25 squared divided by, we're given the radius as what? 20 cm. That is 0.2. So again, I'm going to evaluate this with my calculator and then bring out the answer. Okay, so that gives me 0.31 to the nearest 2 decimal places, meters per second squared. Okay, so this what we do to calculate the centripetal acceleration. Okay, we'll take another question before we end this presentation. A particle starts from rest and moves with a constant angular acceleration of 4 radian per second squared on a circular path. Now, one thing you need to note here is that when you are dealing with this type of acceleration, angular, you should know that tangential acceleration and angular acceleration are related, and is given by the angular acceleration multiplied by the radius of the circular track, circular path. Okay, so now remember that this tangential acceleration, as said in the first question I solved, that it is in the same direction as the direction of motion of the body or particle in the circle. The same direction, something like this. Okay, let's say at a particular point A, the body is here, the direction of the speed or velocity is along the tangent at A. That is the same as the direction of the tangential acceleration, A subscript t. Okay, so two of them. It means that if this AT is constant, if the body is moving in a circle with a constant tangential acceleration, it therefore follows that the equations of motion will apply, because those 3 or 4 equations of motion, of course, they are called equations of uniformly accelerated motion. That is, v is equal to u plus at can apply. This time around, we'll replace this a with our a subscript t, that is to mean tangential acceleration. And we can also write it as V equals U plus alpha arrow times what times T if I replace my tangential acceleration AT with this. Then the second equation also applied, that S is equal to, which is the linear displacement, equals UT plus half AT squared, which is half tangential acceleration times T squared, which can also replace with arrow times T, and so on and so forth. So we are going to apply this equation in calculating the linear speed. Because if you look at the question, we're not giving the linear speed, we're only giving the angular acceleration of this body as 4 radian per second squared. The linear speed is not given, and the centripetal acceleration is not given. We have to calculate the time. At what time will these two accelerations will be equal? Okay, so well, first of all, we need to find the, let's take r as the radius because it's not also given. So let r be the radius of the circle. Okay. Now for tangential acceleration, it is given as angular acceleration multiplied by radius. That will give me 4 times what? R. I can set this as equation 1. Then to calculate the centripetal acceleration, I need the speed. From this first equation of motion, I have V is equal to U plus alpha r times T. Okay. Okay, so that gives me, this is 0 because the body actually started from rest. So my V equals, what's my angular uh, acceleration? That is 4 times radius times T. Okay, this is my V. I can set this as equation 2. All right, so that's to find the centripetal acceleration, AC, that will be equal to V squared divided by the radius R per second. So that gives me 4 r times T all squared is divided by what? R. Of course, the square will affect this 4, that gives 16. It affects this r squared. This r cancels one of the r, so one is left times T squared. Okay, let me call this equation 3. So the question is saying that at what time would the two accelerations, that is their magnitudes, be the same? That is, at what time will I have AT magnitude is equal to AC magnitude? So I'm going to equate the two expressions for the accelerations, tangential acceleration and centripetal acceleration. This was my tangential acceleration 4r, centripetal 16 r not. Okay, so I have to write my 4r here is equal to, what was my centripetal acceleration? 16 rt squared, that is 16 rt squared. Okay, so this cancels this. So I'll divide this by 4, that is 1, that is 4. So that gives me 1 on this side equals 4t squared. So that t squared is equal to 1 over 4. Okay, I need a positive time here. So t equals square root of 1 over 4 is 1 over 2. So it's going to be half seconds. In half second time, we'll expect that the two acceleration will become equal. Okay, we're going to solve one or two more questions in the next presentation. Thank you for watching.